Hello everyone, this is Mike WB8VGE, and today I'm going to show you the progress I've been making on the Heathkit HP1144 power supply. This is a power supply that was originally designed for the SV104 HW104 HF transceivers. It's not very much original anymore, so we'll take a peek. The board with the transistor on in the very back is the regulator / crowbar. It uses the same resistors as the original circuit for the emitter balancing resistors on the two pass transistors. This board right here is, I call it a tie board. It takes the connections from the multi-cable and connects it to the regulator board. I figured this was probably better than usual terminal strips. It's going to be mounted with a little L bracket, or maybe even just a single post aluminum terminal. And back here is the filter caps. There are I take that back, 6,800 microfarad at 50 volt caps. They're on a printed circuit board. The original can capacitors were shot. This is the back of the filter board. There are 600K resistors, 3 watts, used for a bleeder. The bridge rectifier is not original equipment. At least I don't believe so. And it's kind of got a half-ass gob and weld spit solder joints on the transformer secondary. I'm not too sure about those. Wires are kind of rough. I don't know if I'll have enough room to tidy those up or not. But it's a work in progress. Load testing is a solid state DC load, adjustable. And you can see the supply voltage right now is setting at 14 volts. So I'm going to ramp up the current. There's 10 amps. The Heathkit 1144 was actually a crappy power supply. It was only designed to do 8 amps continuous with a maximum of 20 amps peak. I imagine the signal sideband. I set the current limiting, and you'll see it fall on its face when you get to about 17 amps. There it goes. So it current limits at 17 amps. Oh yeah, it's nice and toasty. Do that again. Bring it up. See, right there is 16.5 amps. And it starts to limit. And full limit at 17. And at 10 amps, the heat sinks on the back of the 1144 are politely warm. Current limiting is a function of the voltage drop across those 4 resistors. There's room for 2 more, and if you calculate it out, you can increase the current limiting to maybe 20 amps, although I really don't believe I would do that. I just wanted to touch base on a few odds and ends on this HP1144A project. The SCR overvoltage protection circuit I'm still having an issue with. On the board, the SCR is right here. And when it trips, I'm still reading about 700 ohms between it and ground. I don't believe that's going to be enough to blow the fuse. I'm thinking seriously of taking and moving this over to a smaller board and put it on top of that tie board. That way I'd have a direct connection to the fuse. Might even put a bigger, meaner SCR in it too. The power supply has to be rewired slightly, because when you blow the fuse, you're going to blow it between the rectifier and the regulator board instead of the original HP1144, which popped the fuse on the output side. When Heathkit changed the circuit into the 1144A, they did exactly the same thing. They blew the fuse that went from the regulator to the filter board, or I should say the filter caps in that case. So that might be what I'm going to do. the the filter board, there's not enough holes there for the ground, so I'm going to have to put an extra hole and pad for a ground. And the calculations of the 100K 3-watt resistors is wrong. I just happen to have some of those laying around because there's very little bleeding action off the caps with those resistors, even though there's 6 in parallel. So I'll have to recalculate that and get those values correct. The oh, I want to show you. Here's the filter caps I took out. I don't know if you could see that bulge there on the top. There's another one. See it bulged up? They may have been okay, but well, those would have made a mess if they would have went. So anyway, oh, the wiring I used in the prototype is number 14 gauge house wiring, solid, insulated. Probably if I was going to do this for real, and after all the little bugs and kinks worked out, I'd probably go with 12 gauge solid home wiring, simply because it's relatively cheap and available. And might even think about adding a step start. That bridge rectifier in there, it doesn't look original to me, and with the combined 36,000 microfarads, it might have a short life expectancy getting switched off and on when it first charges that series of capacitors. It's going to be a work in progress, but anyway, I thought I'd let you know some of the little ins and outs of getting this silly thing working. Anyway, that's about all I have for today. I don't know how far this project is going to go. I might offer some printed circuit boards. I don't know if I'll offer them a kit or assembled, maybe just a bag of parts. Don't know yet. There's not much original left in the HP1144 if you put all the boards in. So if some people might say, oh, we got to have an original Heathkit, then you might want to pass on this project. If you don't want to stick this in 1144, it makes an excellent starter for the scanners to start up. But you could use it for other power supplies. It uses a regular IC LM723, so it's a very common circuit. Anyway, that's all I have for today. Next time, we'll see what else we can get into trouble with. I'm Mike, WBVG, from the Heathkit Shop.